Hello students, last time I have given you a homework. Now we solve this homework. Now this question, from this question we start. Now here the question is predict the major product of following reactions. Now first we will see the second reaction. Now here this compound is treated with concentrated H2SO4 and then followed by hydrolysis. That is, in second step it is treated with water molecule, that is hydrolysis is carried out. Now this compound is alkene, cyclohexane, and here there is presence of CH3 group. Now when this compound is treated with concentrated H2SO4, then this concentrated H2SO4 adds across the double bond of this alkene, that is HOSO3H. Now here this is negative part and this is positive part. Therefore addition takes place according to Markovnikov rule. And according to Markovnikov rule, negative part goes to that carbon atom which have less number of hydrogen atom. That is to this carbon atom. And therefore we will get next compound. And here hydrogen is added. Now when this compound undergo hydrolysis, that is addition of water molecule is carried out, then here H2SO4 is removed and formation of this compound or alcohol takes place. OH plus H2SO4. Now name of this compound is 1-methyl cyclohexane 1-OL. 1-methyl cyclohexane 1-OL. Now we are going to see this first one. Now this is propene. This compound is propene, CH3, CH double bond, CH2. When this compound is treated with B2H6THF, that is diborane tetrahydrofuran. Now when this compound is treated with diborane tetrahydrofuran, then here formation of trialkyl borane takes place, that is B2H6THF. Then here formation of CH3. Here addition of hydrogen takes place across the double bond to this carbon atom and boron will attach to this carbon atom. Then we get here CH3, CH2, CH2 3 times and boron plus BH3THF, that is tetrahydrofuran, borane tetrahydrofuran. Now here this trialkyl borane is formed. Now this trialkyl borane will undergo oxidation. Now oxidation is carried out in presence of H2O2, that is addition of 3 molecules of H2O2 are carried out in presence of alkaline medium to form CH3, CH2, CH2, OH. Now here 3 molecules of this propane 1-OL are obtained plus BOH thrice. In this way, this propane is converted into propane 1-OL by these two reagents. Now here, next question. This one. Give preparation of phenol from benzene sulfonic acid. This preparation we have seen last time, and you can easily prepare this phenol by using benzene sulfonic acid. First, benzene sulfonic acid undergo neutralization to give sodium benzene sulfonate, and this sodium benzene sulfonate then fused with NaOH. Then it is converted into sodium phenoxide, and sodium phenoxide on treatment with or by acid hydrolysis gives phenol. Like benzene sulfonic acid, that is this compound. When this compound is treated with NaOH, this NaOH is aqueous. Now here it is acid and this is base. Therefore neutralization takes place to form salt and water. That is the formation of sodium benzene sulfonate, SO3 and Na plus H2O. Now this compound, that is sodium benzene sulfonate, is treated with fused with NaOH. This is fused NaOH. Hit this reaction mixture. Then you will get sodium phenoxide, that is this compound, plus NaHSO3. And this compound, when reacted with water molecule, that is H2O in H+, that is hydrolysis, acid hydrolysis is carried out, you will get phenol plus NaOH. And this way phenol is formed. Then give preparation of phenol from aniline. Now this is diazotization reaction. When phenol is reacted with aniline, when it is reacted with nitrous acid, that is HNO2, in presence of NaNO2 and HCl. This HCl is concentrated HCl, and this reaction is carried out at 0 degree Celsius temperature, that is 273 Kelvin temperature. Then here diazotization takes place to form benzene diazonium chloride. This is benzene diazonium chloride. This is a salt. Now here, this oxygen atom is converted into water molecule, that is twice H2, and formation of benzene diazonium chloride takes place. This is diazotization reaction. Then in second step, this benzene diazonium chloride is treated with or hydrolyzed. Then it is converted into this hydrolysis is carried out in presence of acidic media. Then here formation of phenol takes place with evolution of nitrogen gas plus HCl. Then we are going to see preparation of phenol from cumene. Now this cumene is isopropyl benzene or 2-phenylpropyl, that is CH, CH3, CH3. This is cumene. Now this compound is treated with first oxygen in presence of cobalt naphthalate or in presence of manganese naphthalate in alkaline medium, that is Na2CO3 is used, and hit this reaction mixture. Then here oxidation takes place to form cumene hydroperoxide. This cumene hydroperoxide when reacted with HCl, it undergo decomposition to form phenol and acetone. In this way, cumene is converted into phenol. Now first, give preparation of phenol from chlorobenzene. Chlorobenzene is treated with NaOH at 623 Kelvin temperature and at 150 atmospheric pressure. Then here formation of sodium phenoxide takes place. Plus HCl is removed. Now this sodium phenoxide is hydrolyzed. Hydrolysis of this sodium phenoxide is carried out. Then here formation of phenol takes place. This hydrolysis is carried out in presence of acidic medium to form phenol. In this way, chlorobenzene is converted into phenol. Now next point we are going to see physical properties of alcohols and phenols. In which first property we are going to see nature of intermolecular forces. Now here in alcohols and phenols there is presence of OH group. Now this OH group is polar group. Oxygen atom is more electronegative than that of hydrogen atom. Therefore, it takes away electrons from hydrogen towards itself to form minor negative charge, and hydrogen atom becomes minor positively charged, and therefore polarization of this OH group takes place. Now here what happens, if we consider this is ROH, first alcohol molecule, this is second alcohol molecule, and this is third alcohol molecule. Now what happens here, then this oxygen atom is more electronegative and hydrogen atom is more electropositive. That is, it is positively charged and it is negatively charged. Same case in this compound. And here also same. Now what happens? This alcohol withdraw electron, or this oxygen withdraw electron from this hydrogen atom. Similarly, it can withdraw electron from its neighboring alcohol molecule. This is its neighboring alcohol molecule. It can withdraw electron from this hydrogen atom also, and therefore here formation of a bond, big bond takes place. Now here also formation of such a big bond takes place. Then this bond is called as intermolecular hydrogen bonding. And therefore these molecules of alcohols are associated with each other. Now in case of these phenols, here also same, this oxygen atom is more electronegative than that of hydrogen atom. This oxygen atom is more electronegative than that of hydrogen atom. Therefore polarization of molecule takes place like this. Oxygen acquire minor negative charge and hydrogen acquire minor positive charge. Here also same thing occurs. And therefore polarization of this phenol molecule takes place. Therefore these alcohols and phenols are polar molecules and they can form intermolecular hydrogen bonding. That is, oxygen atom of one phenol molecule weakly bonded with the hydrogen atom of second phenol molecule. And similarly in this case also. And here, if there are number of molecules, then all these molecules get associated with each other. And here, this intermolecular hydrogen bonding or intermolecular forces are shown in these molecules. Second physical property is physical state. Now we are going to see first alcohols. Now these alcohols are colorless, toxic liquid. That is, at room temperature they are liquid in state and they have characteristic alcoholic odor. Now phenols. Phenols are colorless, toxic, low melting point solids. That is, in pure form. That is, pure phenols are colorless, toxic, low melting point solids. That is, at room temperature they are solid and they have characteristic carbolic or phenolic odor. Now we are going to see third property of alcohols and phenols, that is boiling points. Now here boiling point of alcohols and phenols increases with the increase in molar mass. That is, the number of carbon atom and hydrogen atom increases, then boiling point also increases. If number of hydroxy group increases, then also boiling point increases. Now we are going to compare the boiling point of N-butyl alcohol, isobutyl alcohol, secondary butyl alcohol and tertiary butyl alcohol. Now here, from this example, here this N-butyl alcohol, that is, all the atoms in the compound are in a straight chain. Therefore, the boiling point of this N-butyl alcohol is 118 degrees Celsius. That is, here surface area of this molecule is increased. But as the branching increases, for example, isobutyl alcohol. Now here 3 carbon atoms and hydroxy group are in straight chain and 1 methyl group is branched. Therefore, the boiling point of this compound is 108 degrees Celsius. That is, here surface area decreases. Now if we take example of this compound, here all 4 carbon atoms are in straight chain, only hydroxy group is branched. It is secondary butyl alcohol. Now boiling point of this compound is 99 degrees Celsius. And if we take last example, tertiary butyl alcohol. Now here this alcohol is tertiary, or this carbon atom is tertiary carbon atom, tertiary butyl carbon atom, which is bonded to hydroxy group. That is, this tertiary butyl alcohol. The boiling point of this compound is 82 degrees Celsius. From all these 4 examples, we can say that as the surface area increases or as the branching increases, boiling point decreases. That is, in case of straight chain alcohols, the surface area is more, therefore boiling point is higher. But as the branching increases, surface area decreases and therefore boiling point also decreases. Now here, all these four compounds are isomers of each other. They have same molecular formula, that is C4H9OH or C4H10O. C4H9OH or C4H10O. C4H10O. Now here molecular formula is same but structure is different. They are isomers of each other but they have different boiling point also. So this boiling point depends upon surface area of the compound. Next point we are going to see is solubility. Now here these alcohols and phenols, this is AROH means phenol and this is ROH, that is alcohol. Now this is polar molecule. We know that this oxygen atom is more electronegative. Therefore it acquires minor negative charge and this hydrogen acquires minor positive charge. Here also this phenol is polar molecule and oxygen acquires minor negative charge and hydrogen acquires minor positive charge. Now we know that this is water molecule HOH, that is H2O. This is also water molecule. Now this water molecule is also polar molecule. Oxygen atom is more electronegative, therefore it withdraw electron from this hydrogen atom like this and therefore it acquires negative charge and here this hydrogen atom becomes positively charged. Here also same thing, this oxygen becomes negatively charged and this hydrogen becomes positively charged and therefore when this alcohol comes in contact with water molecule, they form hydrogen bonding like this, intermolecular hydrogen bonding. Here also this hydrogen get bonded with this. Here also same hydrogen bonding is observed like this. That is, this intermolecular hydrogen bonding is observed in case of alcohols and water molecule also. Here in phenols also this hydrogen bonding is observed like this. This intermolecular hydrogen bonding is present in alcohols and phenols. Therefore, lower alcohols up to 3 carbon atoms forms intermolecular hydrogen bonding with water and therefore are sparingly soluble in water. But as the number of carbon atom increases, steric hindrance also increases and due to this steric hindrance, the solubility of alcohol in water also decreases. That is, lower alcohols are soluble in water due to presence of intermolecular hydrogen bonding. But as the number of carbon atom or molar mass increases or alkyl group increases in alcohol, then solubility of alcohol in water decreases. Same case observed in case of phenol. Now we are going to start next point, chemical properties of alcohols and phenols, in which first property we are going to see is laboratory test of alcohols and phenols. Now how can we say that it is alcohol or it is phenol, or how can we identify alcohols and phenols or differentiate alcohols and phenols? Then there are some tests, in which first test is litmus test. Now if alcohol is reacted with litmus paper, then here no change observed. That is, if we dip the blue litmus paper alcohol, then it remains blue, and if we dip red litmus paper in alcohol, then it remains blue. From this we can say that these alcohols are neutral in nature. That is, they are neither acidic nor basic in nature. But if phenols litmus test is carried out, then it changes blue litmus to red. can say that these phenols are acidic in nature. Now, second laboratory test we are going to see is reaction with bases. Now, bases or alkalis are NaHCO3, that is sodium bicarbonate, or sodium carbonate, that is Na2CO3, or NaOH or KOH, that is sodium hydroxide or potassium hydroxide. These are all bases. But here NaHCO3, that is sodium bicarbonate, or Na2CO3 are weak bases, and KOH and NaOH are strong base. Now these phenols are weak acid, that is they are weak acidic in nature. Therefore they does not react with weak bases, but they easily react with these strong bases like this. When this phenol, that is AROH, when it is reacted with NaHCO3, that is sodium bicarbonate, then there is no reaction. But when this phenol is reacted with NaOH, aqueous NaOH or aqueous KOH, then here formation of sodium phenoxide takes place plus H2O. Now here this sodium phenoxide is a salt and water, that is here neutralization takes place. Phenol is acidic in nature, NaOH is base, it is strong base, therefore neutralization takes place to form sodium phenoxide and water. This is salt. Now this sodium phenoxide is regenerated. Now here this phenol is soluble in NaOH to form sodium phenoxide. But when it is treated with again with HCl, then it is reprecipitated. That is here formation of phenol takes place with NaCl. That is reprecipitation or regeneration of phenol takes place by the treatment of acid like HCl. Now we are going to see reactions of alcohol with bases, that is NaOH or KOH or sodium carbonate or sodium bicarbonate. Now we have seen that with litmus test or with litmus, these alcohols are neutral in nature, that is they do not change the color of litmus paper, that is these alcohols are neutral in nature. Now these alcohols does not show acidic or basic nature, that is they are neutral, and therefore they does not react with NaOH or KOH or sodium bicarbonate or sodium carbonate. But these alcohols when react with sodium or potassium metal, they forms sodium alkoxide with evolution of hydrogen gas. That is when these alcohols are reacted with sodium metal, then here formation of, now these sodium and potassium metals are active metals, and when alcohols are created with sodium or potassium metal, they form sodium alkoxide. That is here this hydrogen atom gets replaced by this sodium metal with evolution of hydrogen gas. Now we have to balance this reaction. Here there are two hydrogen atoms. Now write here twice. Then here also it becomes twice, and here also twice. And here sodium alkoxide is formed with evolution of hydrogen gas. That is with active metals like sodium or potassium, these alcohols shows weak acidity nature. But actually they are neutral, but with active metals they show acidic nature. This reaction is used to identify alcohol by adding the sodium metal, because here evolution of H2 gas takes place. Now we are going to see characteristic test of phenols. Now here phenol shows color change with this neutral efficiency. That is when these phenols are treated with neutral ferric chloride solution, then here formation of green, violet or purple coloration takes place. Now here the reaction is like this, that is AROH. When it is reacted with FeCl3, this is neutral FeCl3, then here formation of ARO 3 times Fe plus 3 molecules of HCl. Now we have to balance this reaction. Here 3 HCl are formed and here ARO are 3 times, therefore we have to write here 3, then here also we have to write 3. Now the color of this solution is green, violet or purple. That is, when phenol reacts with neutral FeCl3 solution, that is neutral ferric chloride solution, then it turns green or violet or in purple color. That is, this test is given by only phenols, but alcohol does not react with neutral FeCl3 solution. Now we are going to see next reaction, distinguishing test for alcohols. Now here primary, secondary and tertiary alcohols can be distinguished by using Lucas reagent. Now what is meant by Lucas reagent? It is nothing but the mixture of concentrated HCl and zinc chloride. This is Lucas reagent. Now here, when alcohols are treated with Lucas reagent, that is concentrated HCl and ZnCl2, then here formation of alkyl chloride takes place. This reaction we have seen in the preparation of alkyl chlorides from alcohols. Now here the rate of tertiary alcohol, that is the rate of reaction of tertiary alcohol with Lucas reagent is highest than that of secondary alcohol, and primary alcohol is least reactive or less reactive with Lucas reagent. Now we are going to see the reaction. Here this primary alcohol, that is ethanol, when it reacts with Lucas reagent, that is concentrated HCl and ZnCl2, then here formation of CH3 CH2 Cl, but heat is given, then it is converted into this primary ethyl chloride. Now here, if we carry out reaction of secondary alcohol with Lucas reagent, that is concentrated HCl and ZnCl2, then no need of heat required, but this secondary alcohol slowly converted into secondary alkyl chloride, that is secondary propyl chloride, in presence of this Lucas reagent. This reaction is slow reaction but no need of heat. And if we carry out, this is tertiary alcohol, 3-degree alcohol or tertiary butyl alcohol, when this alcohol is treated with concentrated HCl, there is no need of ZnCl2, then it is fastly converted into tertiary butyl chloride plus H2O. From this reaction we can say that tertiary alcohol is more reactive with Lucas reagent. Then secondary alcohol is more reactive than primary alcohol, and primary alcohol is less reactive with Lucas reagent. So we can give the heat and then we can convert this primary alcohol into alkyl chloride. Secondary alcohol, there is no need of heat, but slowly reaction takes place to form secondary alkyl chloride, and tertiary alcohol are converted into tertiary alkyl chloride fastly with concentrated HCl.